So what we can also do is click and drag these waveforms. Let's go ahead and click, get the arrow on the waveform, click and drag down with the mouse. Then you can see that we can separate the waveforms or we can overlay them. On the left, it shows some of the stimulus parameters, 30 dB, IPSI, and 2000 Hertz. The other thing you can do is if you select it, on the right, it'll highlight the file in which that waveform corresponds to. If I go ahead and select this one, you can see that the waveform is associated with that file there. You can also double click on it to find out what waveform is corresponding to that, and it will briefly flash the color green. This becomes helpful when you have two waveforms that are overlapping, as you should do for replicating, and you're unsure which waveform is which, and you can just double click and see it to be able to click and drag it away and separate the two. The other aspect of this is that you can double click on it and make sure that that's the waveform you're looking at with respect to the signal to noise ratio up here at the top and the residual noise level. If you go ahead and double click the other file, you can see that the signal to noise ratio and residual noise changes. If we're satisfied that we want to do some post-processing on these two replications, you can select both. We can average them by clicking the average button. It takes a second or two, and the average comes up. And the averages in this program are always a thicker line and automatically get labeled with an AVG at the end of the waveform, as well as a marker in this little dot here, which you can drag to anywhere you like, showing the signal to noise ratio and residual noise values. You can also move the text in any of the 4 quadrants that you like. And that's the same thing for any of these markers. And we can click and drag that to wherever we want. To mark your waveforms, which is important for doing ABR, we have on the top here markers for wave 1, wave 2, wave 3, wave 4, and wave 5. So go ahead, we can select wave 5 marker. You'll see cursors come up. Click again, and it puts the cursor where markers where that cursor was located. And you can see here it marks it with a Roman numeral 5 and the latency value. You can click and drag the marker down. It currently is showing 0 nanovolts because the marker hasn't been updated. It will show 0 because that's where these two were next to each other. If you go up to here at the top, you can click on this red arrow, circular arrow, and it will update the marker for providing the information of the wave 5 amplitude is shown for the 5 prime, and the latency of wave 5 peak is shown next to the 5 marker. To turn off the latency and amplitude values, click on the black arrow and they go away. Again, selecting the red makes them appear again. So this is the basics of the sABR program of recording replications, averaging them, and adding markers to them. We can also add a marker of our choice. We could even say that this is a 39 Hertz stim rate. Select OK. Again, cursors will come up. Click on that and you have created a marker at that location. So another thing we can do here is change the x-axis down here at the bottom, minus 25 to 25. That's the extent of the ABR. So you can see this no ABR in this pre-stimulus area, and then an ABR at time point 0 to 25 milliseconds. We'll change this back to 0 so we can see the ABR. We can also zoom in by changing our Y scale to be, let's say, 1. And you can see that we're looking at just that average. Or if we go 0.5 back to 1.5, or even 1.25, we can see we can change the scale to make the wave 5 look quite a bit more prominent and obvious in the recording. For demonstration purposes, we'll change that back to 0 to 1.5. And we will move now to recording a ABR in the right ear. For demonstration purposes, we're going to change our stimulus. We're going to go to a rare fraction click, and that defaults at 80. What you will have seen is that this scale on the x-axis defaults now to -2 to 12.8 milliseconds. Those are the default values for doing click ABR. Okay. The click ABR intensity for rare fraction is set automatically at 80. You can change this. We have a frequency which is rare click. Our type is AC, air conduction. The rate has now automatically changed to be 19. With click ABRs, we record at slower rates. And stimulating, now we're going to stimulate the right ear, so we can see the plot come up on the right. Channels IPSI, and our sweeps per 1,000. I'm going to go ahead and click on this online button, so you can see the click ABR response acquire over time. Click acquire. You can see our general noise coming out through here. And this is going to take about a minute or so to record 1,000 sweeps of the click ABR. So I'm going to pause it here and then come back in about 30 seconds and show you the result. Okay, well, it's just finishing off there. We have a click ABR, 1 replication, and for sake of viewing time, we're going to turn off the online and just click acquire again, and we get a second recording, which I'm going to click and try to drag and overlay as best as possible. Now what you can see here is that there's a replicating waveforms happening, and this is a child age 1.5 months. So this might not look like, if you're used to doing click ABRs in adults, might not look quite typical because some of the waveforms look delayed. But this is the standard maturational effects that we get in infants to adults. So I'm going to go ahead and average these. Select the two, click on the average, and an average comes up. Again, we have the designation of average, signal to noise ratio, and RN values. And what these waves represent are wave 1, wave 2, wave 3. Embedded in here is probably a wave 4 and a wave 5 and possibly wave 6 there. Okay. So we can go ahead and select our labels. Click on the cursor, drag the 1' down. There are 2 markers that come up, the 1 which is the peak and the 1', which is going to be the measure of the amplitude. Select on wave 2, just to be thorough here. Wave 3. And because I can't really see a wave 4 here, I'm just going to go and bypass that one and then select wave 5. And then click the wave 5' down to be within the most negative point within 6 milliseconds of this peak. Go ahead and select that red arrow to update the amplitudes of the primes. So now we have a click ABR recorded in this infant at 1.5 months of age with all of the labels of each peak. So one of the major benefits of using the sABR program is to know what the ground truth is. So we can actually determine what the underlying ABR is of this click ABR or even the 30 dB 2000 Hertz tone ABR. How we can do this, if we look at their ongoing EEG, we have that's our noise structure that's embedded on top of the ABR. We can simply turn off the noise. So there is now no noise going into this that'll be overlaid on top of the actual signal. So we can extract the signal by simply doing the same recording with our noise turned off. So we do that and we can see a waveform came up on the top, and now this is the real or simulated ABR signal without noise. Let me click and drag this label to get it out of the way. And what we can see is here's wave 1, wave 2, wave 3. This could be a 4-5 complex here. So what's nice about using the sABR program is you can confirm what you think is a peak and not be misled in thinking that it's noise. So let's go ahead and then change back and see our tone ABR 2000 Hertz response and what it should look like. So again, the axes changed back to 0 to 25 milliseconds automatically, and it put the default settings for this. Our gain of our noise is 0. We also need to change the ear back to left. Go ahead and select that and hit acquire. And you can see the ABR waveform come up without any noise. And that's to help us confirm that what we labeled originally in this waveform is truly an ABR response. So this concludes the first tutorial on the sABR program, and I hope you enjoy going and playing, turning off and on the noise and recording ABRs under different noisy conditions, as well as across the different types of stimuli that we can provide in this program. So thank you for taking the time to going through this tutorial, and most of all, enjoy playing around and simulating ABRs and have fun. And now for the typical announcements, please subscribe, rate, like, provide your comments down below, and send this off to your colleagues or friends who just want to play with sABR. See you again soon.